Welcome back to the Organic Chemistry Reaction app Devlog. This is Devlog number 8. And actually, before I begin, I think I need to say this app is released. You can download it right now from the Google Play Store, or you can play it on any device in your browser at itch.io. Here are some QR codes for you to scan if you want to get to the links, or you can check the links in the description as well. By all means, give the app a go. I had some people tell me that the app sounds interesting and they're excited for it to be released, and I'm like, it's already there. You can play it right now. So I guess I learned that I need to be a bit more upfront about the fact that the game is available and that you should play it. So yeah, there it is. But today I want to talk about databases. I think I said that I showed this slide for the last time a while ago, but I guess I lied. Here it is again. In the past, I used this to show basically the front end of the game, where you solve puzzles basically permanently. I had a different side that also described the back end of the game, but I don't think I ever talked about where the database fits in. Well, it fits in right on the dotted line. The goal for me is to reach a point where I'm never changing anything in the game, not the front end, not the back end. But the goal is to always be updating the database with new puzzles. So this software will remain the same, but will continuously be updated because the database keeps growing. And that basically makes the database the most important part of the app, because that's where all of the information is. So what is the database? Basically, it's an array that contains data about the puzzles. Not the puzzles itself, mind you. Those are XML files. Though I guess the database points to those files, so in a way the puzzles themselves are related to the database. But actually the database contains information like what's the puzzle number, what's the difficulty rating for the puzzle, what's the reaction type, the key functional groups, things like that. So it's for sorting through puzzles, I guess. The database pretty much only interacts with the game during the puzzle selection process. And right now there are 3 ways to select the puzzles. First, you can enter a puzzle number and load that puzzle specifically. In this case, the app just searches the database for that puzzle and fetches the XML data for that puzzle. Second way you can do it is to use the full random feature. This one basically works the same way as the selected puzzle, but instead of having a user input puzzle number, it uses a randomly generated puzzle number instead, but otherwise it's the same. And finally, we have the targeted random feature, which is the feature that I intend to be the main way to play this game. The feature gets 10 random puzzle numbers, fetches the difficulty rating for each of those puzzles, and then finds out which of the 10 puzzles is closest to the player's skill rating, then gets the XML data for that puzzle specifically. All right, so what's actually in the database, I guess? First, there are what I guess are called critical elements, the puzzle number and the difficulty rating. The puzzle number is actually just the row number for the array that identifies the puzzle you're talking about. So row 1 is puzzle 1, row 2 is puzzle 2, etc. And that's important because you need to know what puzzle you're talking about, obviously. The difficulty rating is there for 2 reasons. First, like I just mentioned, it's there for targeting puzzles that are close to the player's skill rating so that you can get appropriately challenged by the app. But second, it's there to help adjust the player's rating after they get a puzzle right or wrong. And I think I talked about how that works in a previous devlog, so I'm just going to leave it at that. I call these 2 critical because they're necessary for the function of the game as it stands. We need to know what the player's skill is and how to adjust it. And we need to know what the puzzle number is so that we can identify puzzles. Without those 2, then the game doesn't really work, or at least the puzzle won't work, the puzzle that doesn't have those entries. Everything else could theoretically be left blank. So yeah, after the critical elements, there are also the puzzle type elements, I guess we can call that. These don't do anything right now, but I'm planning to use them for future capabilities eventually. So for example, somebody might want to focus their practice on reactions involving a specific functional group, like alkene reactions or carbonyl reactions or halide reactions. Eventually, I'd like the game to be able to handle that level of customization in the puzzle selection process. And so I made a column for reaction or functional groups for each puzzle so that you can identify this puzzle is an alkene reaction. And later on, maybe there'll be features to use that. Likewise, somebody might not want to focus on functional groups, but rather on reaction types, like substitution reactions or hydrolysis reactions or additions, whatever. So I have a column for that too. And so you might have something like halide SN2 as the functional group and the reaction type. And eventually people will be able to search for that and only look at the puzzles that they want to see. I guess I could also use these puzzle or these columns to identify overrepresented and underrepresented reaction types, and then try to balance out the different reaction types that the gameplay is appropriately varied in general. So for example, if I see that there's too many SN2 reactions, then I'll just stop making SN2 reactions for a while. Or there's not enough alkene reactions, then I can start making more alkene reactions. I haven't done any of that yet because I'm just kind of working through a data set that I have. But eventually, maybe I'll do that, and that it could be a good way to balance out the variety in the game. Who knows? Lastly, in the database, I have what I'll call the identification elements. I use these basically only to make sure that there are no duplicates of the same puzzle. After all, what good is having 1,000 puzzles if actually 100 of them are all the same reaction, like sodium hydroxide reacting with acetic acid? Right? It's functionally, there's actually a lot less than 1,000 puzzles in that case. So duplicates are no good, and I don't want them. To avoid this, basically I've been using the inchy keys for the reactants. If two puzzles have the same two inchy keys and no notes as to why, then basically they're probably the same reaction, and I need to remove one of them because it's the same puzzle. I do have some that are duplicates, but some are like this reaction occurs at low temperature and a different reaction occurs at high temperature. So even though the reactants are the same, the conditions are different, and I make note of that as well. Now anyway, what is an inchy key? Because not a lot of people maybe will know what an inchy key is. Basically, they're unique identifiers for specific chemical substances. According to Wikipedia, they're designed to allow for easy web searches of chemical compounds. And this seems to me more like a software-focused identifier and not something for humans to use. So basically, it's something that programs can use while searching through databases. That way, if you look up an inchy key, you can be sure that you're going to find specifically what you're looking for. So yeah, it's for software, and it sounds perfect for this application. And it is perfect, really. I just hate it. Inchy keys are not related to chemical structures like at all. They're actually hashed versions of regular inchy identifiers, which are related to structures. I've actually never used inchy identifiers before, and I don't really know how. I guess I should learn it at some point, because it's a lot easier to turn inchies into inchy keys than it is to do it in other ways. You can see an example on this slide for puzzle 16, which has an inchy key for isobutylene and for hydrobromic acid. The thing is, those two just strings of text don't really correspond to those things at all, and if I didn't have the chemical structures right below the inchy keys, then you would never know that those inchy keys relate to isobutylene and hydrobromic acid. So yeah, it's just a random string of text, and it's hard to work with if you don't know what you're looking at, and you don't because you're not a computer. It's annoying because it said that these things are designed for searching, but in order to search using them, I need to know what they are, and I don't know what they are. So first I have to do a search without them using something like the IUPAC name or the chemical structure. So inchy key is not really useful for searching unless you already know what the inchy key is, and I don't, so I have to search without it, and that's a lot of work. And even though every chemical has an inchy key, not every chemical is in a database. So for example, like PubChem, oftentimes when I'm looking for inchy keys, I'll search PubChem for the structure that I want, and then pull the inchy key from PubChem. But if the chemical isn't in PubChem, then I can't pull the inchy key data, and I just don't know where to look. So it's really hard to find these. And another annoying thing is that 2-butanol has an inchy key. It's on the screen right there. But R2-butanol actually also has an inchy key. And that inchy key is different than that of the racemic 2-butanol, or the non-stereospecific 2-butanol, whatever you want to call it. Furthermore, S2-butanol has a different inchy key. And so all of this just adds to my frustration, because it's hard enough to search for a chemical structure without stereocenters involved. But now I need to not just have the generic chemical, but the stereospecific version of it. And that's, because sometimes the S enantiomer will do a different reaction than the R enantiomer, and I have to specify that. And it's really frustrating, really hard to search for. And searching for NG keys turns out to be tough work. At this point, it's taking me basically just as long to find inchy keys as it does for me to make the entire puzzle. And I hate doing it, but I need the information, so I have to. Fortunately, I did recently find a website that lets me draw structures, including their chiralities, and then tell me what their inchy keys are. So it converts structure directly into inchy key, which apparently not a lot of things will do. This website was not easy for me to find, and I couldn't tell you how I found it because I tried to look it up now and I can't find it again. But I did bookmark it, so I'll never lose it. The link is there. Thank you, Cactus, and thank you, National Cancer Institute, because that link is a godsend for me. One more deal with the databases is that it adds challenges for scaling. The larger the database, the more work there is when I add new features. This, I guess, isn't so much a database problem as it is a number of puzzles problem. But, number of puzzles equals the number of rows in the database, so it's kind of a similar thing. But yeah, not specifically database related, but I'll talk about it now. One example of this is when I added the reaction scheme feature for the info screen in a recent update, so that you could look at the overall reaction and then decide what mechanism you think was going to happen. In order to implement that, I had to go through every puzzle I ever made and manually enter in new data to accommodate this feature. Now that was like 300 puzzles to go through, which was not fun, but 300 is not a lot. Imagine instead if I had 10,000 puzzles. It would have been 10,000 puzzles to manually go through, and that would be rough stuff. Even the inchy key thing, I have inchy keys for the reactants, and I still don't have all of that data down. Because like I said, I hate looking for inchy keys. I'll get it all in there eventually, but yeah, it's just, fortunately there's not 10,000 inchy keys to go through. I guess I'm bringing this up because this is going to be a recurring issue as I build new capabilities, right? If I make a new feature for a new puzzle search thing, I don't know. As I scale, there might need to be new edits to the database or new edits to the puzzle XML files. And when I do that, the more puzzles I have, the more work it's going to be. It'll get worse every new feature. I try to avoid that, but obviously you don't know how to plan for everything, so you get caught off guard. I guess my advice to you, if you're making a game like this one with a plan to scale basically to infinity, I guess you better be prepared to deal with infinity in the case that you miss something. So yeah, that's just me complaining. Other news anyway. I'm about to roll out version 1.0.3.2, which is going to add more puzzles, and that's about it. That's my goal, is to just make puzzles. If I add other things, it's basically somebody's forcing me to. Not forcing me to, but it makes me feel bad, and I have to fix it or add this thing. So that's why I add new features. But mostly I'm just making puzzles. I have 452 right now. I also identified 2 bugs, so those are things that I gotta fix them, but I'm gonna fix them later because I found them very recently, and they're not game-breaking, I guess. But there actually might still be a problem where if you're loading the app for the first time it would get stuck on the loading screen. I thought I fixed that, but maybe not. It's hard for me to replicate when I'm just sort of working on like a, I don't know what you call it, like the preview version of the game, like in the Construct 3 program itself. That bug doesn't exist, and so I only see it when I export it and I put it on my device, my cell phone, and then suddenly it doesn't load. I'm like, I didn't fix this. So it's hard for me to troubleshoot. If you're having problems loading the app for the first time, just restart the app and it should go. There's something wrong with the first load, but if you just start it over again, it works. I don't know. This release also marks the end of a section from the references I'm using to make the puzzles. And this section focused on halides and SN1, SN2, E1, E2 reactions. So that makes me excited because that means I get to move on to a new reaction type. And yeah, I'm always happy to do that because the game needs variety. I think right now it pretty much only has alkene/alkyne reactions, which are pretty much the same, let's be real. And halide reactions. So it all feels as a little bit samey, at least when I play it. I don't know. But that is changing with every passing day, and we'll move on to new reaction types and new functional groups. And eventually we'll have built out, at least the full second year organic chemistry curriculum, moving to the third year organic chemistry curriculum, and then beyond. We'll get there. Other news, actually, I'm going to have a poster presentation at the Canadian Chemistry Conference this year. So I don't know if anybody who sees this is going to be there, but if you are, then you can come and say hi. I think that'd be pretty cool. I actually submitted for a talk and a poster, but the talk got rejected, and they said you're going to do a poster, so now I have two posters. I got to cancel one. But yeah, the committee probably rejected it because they were like, this guy's not affiliated with the university. Get him out of here, right? So, whatever. I'm like, yeah, whatever, man. My project is probably too cool for school, and that's what the committee thinks too. All right, that's that. As always, thanks for watching, and I hope to see you next time.